Hi guys, greetings from Bulgaria. It's already a rainy season after really hot weather here, so it's much better. So I'm ready to record yet another video for our Selenium series. Let me share my screen. So I'm Anton Angelov, your host, and this is another video from our Selenium 4 course. Until now, we talked about how to automate sign-up forms. It's really a little bit longer video, but it's really essential, so check it out. Then we talked about interesting strategies and different services for automating emails and working with them in with Selenium. Then we talked in depth about handling captchas and even some AI solutions for solving them for testing purposes. And in the latest video, we discuss what is the role of web cookies and how to work with them and how you can use them for optimizing your tests. In this video, we're going to talk about, from the LambdaTest channel, we're going to talk about how to handle weights in Selenium and the different problems with them. Of course, thanks to LambdaTest channel, don't forget to subscribe to the channel, hit the ring bell so that you get notified about the awesome videos that are published each week. And don't forget to check the blog, because there are many blog posts there that are really detailed, talking about each of these different problems from different angles. So let's talk about weights now. By the way, for this particular video, I'm going to use many of the examples that I use for, I wrote like 1 year ago for my best-selling book, Design Patterns for High-Quality Automated Tests. In chapter 2 and chapter 3, actually, most of the time I'm talking exactly about this problem. So I thought that maybe I can share this for free with you. So let's discuss the example. I created this demo website called, it's basically like a regular online shopping cart for selling rockets. In a couple of other videos, I also used it. Basically, you can just purchase different items. As you can see, here the website is using asynchronous JavaScript technologies, meaning that basically we are not going to reload the whole website, but just part of it. And using this AJAX asynchronous JavaScript, we're just making HTTP requests to the server and calling some internal APIs of the website. And as we'll talk about later, when we have such architecture of the website, sometimes we have problems in our tests if we haven't written them in the best way possible. Especially, for example, when these spinners occur like this, and if you try immediately to click on the button, you will notice that you will receive an exception, an error. In the next video, we're going to talk much more about all the various kinds of Selenium exceptions and how to overcome them. But in this particular video, again, we're going to talk much more about speeding up the tests and handling these asynchronous problems. So this is the next page where we have the card. We can, again, this asynchronous stuff. For example, if we update the card, you see all of these spinners. Again, if you try immediately to update the card or proceed while the spinners are there, your test will fail. And one way to solve that is to use hard-coded pauses using thread sleep. In a minute, I'm going to show you the implementation of it. So when we update the card, we want to check all of these prices, whether they are correct or not. Or, for example, when we remove an item, you want to check that the prices are fixed. And then the next part of the test is just filling out all of this billing information and place the order, just like a regular shopping cart. That's all. And now let's look into the tests. We're going to see a couple of examples how to handle these problems. Of course, the first one is not the recommended one, but many people just do it because it's the simplest one, just to use hard-coded pauses. Then we're going to talk about much smarter approach using the internal Selenium ways, using their internal weights, implicit and explicit. And then I'm going to show you a few simple design patterns, how you can reuse the code and follow more closely the do not repeat yourself principle, where we're not just copy pasting code everywhere, but we're going to group it in a little bit more maintainable manner. So, by the way, you can find in the description below many of the different resources, like an articles and links to other videos. And also you will find a link to the GitHub repo where you can download the whole source code for all of the previous videos, etc., and you can play with them. So I grouped here, the examples in a few different packages under the hard-coded pauses package. Here is the simplest first implementation, first version, where basically I automated two scenarios of this website. We are using WebDriver here in the test init. Basically, before each test, we are going to initialize the driver using the WebDriver manager package library that I reference here in the POM XML. Then I'm starting the Chrome browser and using this implicit wait, which is basically the general timeout in Selenium, which is basically this wait allows you to hold WebDriver for a specific period of time until the WebDriver is able to locate the desired element of the page. But we can even skip it for now. As I said, we are going to use hard-coded pauses. The big problem with this general timeout is that sometimes you may need more than 30 seconds. And in order to handle this, you have to increase it once more. However, this means that you will wait more time on places where basically you need to wait shorter, and this will prolong your test and it will execute for more time. And imagine that you have 100 tests, you can multiply this 10 additional seconds. This is huge delay. So again, no design patterns, just plain code here. There will be separate videos about how to group the test better, etc. Just for simplicity, I put everything directly in the test, which is not the best practice, just for really quick, simple tests. So here we navigate to the page, and everywhere I just used the find element methods with different selectors like CSS, ID, or XPath, and simple commands like clicking, like send keys for typing the text, like the coupon for discount. And again, in order to handle the asynchronous spinners everywhere, for example, if we return to the example here, imagine that we have happy birthday, I think this was the coupon, and when you apply it, we have the spinner. But sometimes again, when there is a significant vote on the website, you have to wait much longer, and this is why here this is one of the first pauses. Basically, through this thread sleep, we are waiting for 5 seconds for spinners to disappear, and we're doing the same thing with navigating between the different pages because they're loading again asynchronously. So as you can see there, on many places, many of these hard-coded pauses. This is the place for where basically we are filling the billing information. When, for example, when we increase the count and when we click the update button, again, we need to sleep again to wait for the prices to be updated. And again, this website uses modern JavaScript technologies, and most of the operations are asynchronous. And as I said, this is a bad practice with these hard-coded pauses. With these pauses, we added like something, if we need to count them, a little bit more than 35 seconds on top of the standard execution time. And sometimes these pauses may not be enough, leading to probable test failure. Other times the element might be already there and there won't be a reason to wait for the whole interval, right? And again, you may need to wait for a larger wait interval. Again, one option is to increase the global timeout, but this global timeout here, implicit wait, instead of 30 seconds to wait for 60 seconds. But this will affect all of the existing tests. Another option is to mix implicit and explicit wait, but this is not recommended. What is the explicit wait? Here in the second package called WebDriver wait, let's now use the explicit wait. For the explicit wait, we are going to define two additional methods to fight this. So instead of using directly driver find element, I will just create a wrapper here called private void. Actually, it will return web element, and I will call it find element. This is just an internal method of ours directly here in the tests, but later I will show you how we can reuse it. And then here I'm going to define, in many of the different videos from Selenium 4 series, we already use the WebDriver wait or the so-called explicit wait. Basically it will allow you to the waits allow you to stop the execution of a script based on the present condition for a specific amount of time, right? And in our case, we will WebDriver wait new WebDriver, where basically you need provide the driver and the time that's the default timeout. In our case, this will be 30 seconds. You can really, if you want to make your tests following the best practice, you may use a constant here. And then you call the until method, where we're going to, in this until method, we can use lambdas, or if we have a function, which is basically a pointer to a different method. In our case, we use this static methods from expected conditions. And here, this will internally check in a big while loop for the element to be present. It will sleep a bit, and then it will return here. This means that if the element is there after 2 seconds, then we'll continue, which is like a smart wait, right? And again, as we'll talk in the next video about handling Selenium exceptions, there are many of these methods here. Like, for example, you can wait for element to be clickable. We can wait for a particular frame. Again, in the next video, you will see that there are some exceptions regarding whether the frame is there or not. We can wait for many of different elements. We can wait for element to be not present on the page, because in certain cases we need to wait for that. And there are many of them. So we can define one more of these methods, and in case of we need to basically wait for group of elements, right? However, the method here is different. Here is presence of element located, and here is presence of all elements located by, right? And again, this until method will return the actual element. You don't need to call driver find element afterwards. It will return directly the web element. And our job here is to, I'm not going to refactor the whole test, but basically instead of calling driver, we need to refactor the test. Instead of calling everywhere driver find element, we just called our internal implementation of find element, right? One easy way to, and again, we need to repeat that everywhere. And after that, you can remove some of the hard-coded pauses. This will, again, improve significantly. This will improve significantly. I already did this refactoring, so here it is. I just refactored it a bit. However, it cannot remove all the hard-coded pauses because in certain cases we are not really looking for another new element, but we need to wait for process to be updated or whatever. Maybe instead of waiting for the element to appear, we can wait for text to be different. This is a possible strategy to handle that, and maybe we can remove this hard-coded pause. But I'm in a minute, when we discuss to the simple design patterns to group that, I'm going to implement another method called wait for Ajax, where we are going to use small JavaScript snippet, which will wait for Ajax request to finish, and then we'll continue, and this will allow us to remove this additional hard-coded pause. But again, like we removed like 15 seconds of hard-coded waits. This means that probably we'll wait just for 5 seconds and then we win like 10 additional seconds, which is great. So now, again, all of this code is one way to reuse this among your tests is just to create a base test class and move these private methods there and make them protected and then access them across your tests. But really, maybe there is a smarter way. One of these ways is to, I'm going to show you two simple design patterns. The first of them here under the main package Java. Again, I like to separate the tests from helper classes, like framework or whatever. Even you probably, if you have a separate, a complex framework, I suggest to create different modules for that and move it there. But still, test folder is only for tests. If you have page objects or other design patterns, move them at least under the main folder. So here I created just an empty class called WebDriver Proxy. What is the proxy? Proxy design pattern, we can mix it together with the explicit weights that I already showed you to solve the same problem, but like in a more elegant way, and reuse these find methods. And if we need later to add additional logic, we'll add it just into this class, and then it will affect all of our tests immediately where we use it. So basically, the proxy design pattern, it provides a placeholder for another object to control access to. I know that this is like really vague, but basically this class, you can think of it as a wrapper, and we are going to wrap the WebDriver and the WebDriver weight. And we're going to use the so-called composition principle. In a minute, I'm going to explain what is that. So the proxy pattern, in order to implement it, we'll just implement this class, will implement directly the WebDriver, because this is an interface that actually the Chrome driver and Firefox driver are implementing. So we can create our own implementation of it. We need to, IntelliJ can generate all of these required methods. And here we need to override all of them and provide an implementation. So what does it mean, the composition principle? For the composition, basically we are going to, in the constructor, we are going to supply the actual implementation of the WebDriver, meaning from driver, Firefox driver, and we're going to wrap it here. And the composition principle in object-oriented programming is the principle where classes should achieve polymorphic behavior and code reuse by their composition, by containing instances of other classes that implemented the desired functionality, rather than rather than inheritance from a base or a parent class. This is especially important in programming languages like Java, where you cannot inherit multiple classes. This is not allowed. More or less, we don't have base class where we get the WebDriver, but instead we are using it as a private variable. That's all. As I said, the proxy is just like a wrapper where we can add additional logic in just this particular class. That's all. But the big difference between this pattern and the next that I'm going to show you is that we're directly implementing the WebDriver interface. It stays absolutely the same. We're just adding additional logic on top of it. That's all. Directly here, for most of the methods, we're going just directly to call the driver, right? For example, to get the current URL, we're going to call driver get current URL. For title as well. And we can do the same for the rest of the methods here, right? It's basically except find elements and find element. All other methods are directly calling the same methods from the actual driver implementation, from driver or Firefox. The biggest difference is here in find elements and find element. And guess what? We're going directly to reuse the logic that we already saw here. Basically, we will directly copy paste these methods here to reuse them, all right? Since we are initializing the WebDriver wait here, we won't like here initialize it every time, right? And this is the actual implementation. Here, instead of directly calling driver, find element, whatever, every time we wait first for the element to be there, and then we are going to return it. Awesome. And even, for example, for here we don't have a click, but you can implement the same for example, you can create a proxy for the element, and for example, when you want to click it, you may again call WebDriver wait, and we can wait for element to be clickable, and then click it. And again, as we will see in the next video from the series, this will help us to protect against a few nasty Selenium exceptions. And now for the tests here, for the implementation, instead of using these private methods, by the way, here in the recent update, this was deprecated, implicit wait, and we need to use duration of seconds 13. And next, instead of, we need one additional line. Here we'll have under WebDriver, we'll have WebDriver proxy, and then when we initialize the driver here, we will have a proxy driver, right? Like this, proxy driver. By the way, it's doable even to do that because it's implementing the same interface. Instead of proxy driver, we can eliminate that, and you can reinitialize the actual driver because it's implementing the WebDriver interface. No change whatsoever. We need just to remove, you know, all of the hard-coded pauses. Everything else stays the same. As you saw, really quick, we re-implemented that. Actually, here it's not a proxy driver, but yeah, you get what I mean. Basically, we can remove not some of the hard-coded pauses as we did for with these private find elements where we use the explicit way. And now, one more pattern. As you notice right now, the huge difference between the two patterns that I'm going to show you is that here we implemented directly the WebDriver interface, and this is why we could directly, you know, initialize the WebDriver proxy to the driver itself. However, sometimes we may want to change the interface a little bit. Why? For example, some of the methods are a little bit vague in WebDriver, and also you may not need all of them, or you may want to add additional ones. For example, the wait for Ajax method that I told you about. And or for example, you may want to ease the creation of the driver itself. And for this purpose, we can use the adapter design pattern. What is the adapter design pattern? Basically, it allows you to adapter allows you the interface on an existing class to be used as another interface. This is why the official explanation of the pattern, but more or less we'll do almost the same thing, but we'll change the interface, and we'll have additional methods there. What is the interface? This time I will change both interfaces, the driver and for element. For the driver, in order to implement the adapter design pattern, we need to create an interface or an abstract class. It doesn't matter. Both ways you're like creating an interface for that. In my case, I implemented that as an abstract class. And as you can see, this is a little bit different than the WebDriver interface. First, we have this factory method that accepts this enumeration, which is basically the type of the browser that we want to initialize. Then it's called start. This is a factory method, and in a minute I'm going to explain what it's doing. Then we have the quit, which is in the standard interface as well. Then we have go to URL, which will be a shorter version to the version in WebDriver, just for usability purposes. Then we have this new method called wait for Ajax, and we just have these two find element and find elements. But as you can see, we don't have many of the rest that we actually don't use in our tests. I did something similar to the interface of the element. Instead of having web element, now we have this abstract class called element. And the biggest change here is that actually the element now knows how it was located. And this is really huge because actually it allows us to reuse a lot of code, reusing especially the locators. Then we, instead of having this weird method called send keys that it's used for many different things, we now have only type text, which will type text in a field. And we have a few others. And the actual implementation of the pattern is directly in the adapter class, right? Which basically implements or extends the abstract class. Again, as I said, you can implement it with interface or just with the abstract class as I did. It's absolutely the same. Again, we use composition here. We have the WebDriver and the WebDriver wait. this time, instead of in the constructor, they're initialized in this factory method called start. The whole point here is that we have this huge switch based on the type of the browser, where we download the correct version of the driver using the WebDriver manager, and then we initialize the Chrome driver for production purposes in your framework. This can be much more complicated and complex, especially if you use the Chrome options, the options classes, or imagine that you want to run the test in LambdaTest or other cloud. Then here this will be much more complex, but for now we'll stick to that. And next, I'm initializing also here the WebDriver wait. For the quit and go to, as I said, this go to is like a simplification. Instead of having this first to code is navigate and then to, I just have one go to URL method. And then for find element and find elements, as you can see, it has additional logic, because right now this is the place where we're initializing the element adapter, the change interface of the elements as well. First, we wait for the element to appear. We return it in this private variable here, native web element. And then I'm just calling element adapter. We provide the driver, the native element, because we are wrapping them again, as you'll see in a minute, using composition. And then we provide the locator. This is how our element adapter knows how it was located. And then we return it, that's all. And we're doing the same for find elements, but we're iterating through all of the native elements that we found, and we initialize here a list. And here is the wait for Ajax logic, where we're casting the WebDriver to JavaScript executor. Basically, we're getting the we need to cast it, because if you use directly the Chrome driver, for example, it directly has this execute script methods. However, not all of the drivers have it, so this is why we need to implicitly cast it. And then we're using the WebDriver wait to execute this particular script until it returns 0. This means that there are 0 active requests using jQuery Ajax. Of course, you can use that only on pages that are using jQuery, as in our case. And then does the actual implementation. And instead of proxy, we'll just use driver adapter. It's basically the same thing. And what about the element adapter? Again, as I said, we are using composition, meaning that we use them as private variables here instead of having a base class. We're extending our base class for the element, which again defines the new interface. This is the big difference between the two patterns. And then here is how we initialize and how actually the element adapter knows how it was located. We just provide this. Native web driver elements, they don't know how they were located. And then most of the time we are just returning directly the native element methods, like getText, or whether it's enabled or displayed. Just for the type text, we are clearing the inputs, then we're using same keys. Again, this is how we change the interface, making our test a little bit more readable. For the click, as I said, this is one huge, again, here we need to refactor that duration of seconds 13. You can move that to a constant for best practices. But yeah, basically we're waiting for the element to be clickable, and then we click it. This is one way to protect against different Selenium exceptions. And next, in our tests, here for the adapter, again, everywhere, instead of driver, we are going to initialize here the driver adapter. Let's see how to do this refactoring. Now, because we have a different interface, we won't be able to reuse this here. And now in the test init, because now we don't need this code because we are calling WebDriver manager inside the start class, we just initialize the driver adapter and we call driver start the different methods here. And what about the rest? Let me show you. Now, everywhere, as you can see, it's again find element because this is how we implemented but actually this is returning our abstract element adapter base class. And this means that when you click here, first we will wait for the element to be clickable, then we will click it. And also here, notice that actually we are using the new type text method, right? Which will first clear the input and then we're going to type the text. And here we don't have any more thread slips. We already have access to wait for 𝒏𝒕𝒐𝒏. And also another difference is that we don't call driver.navigate_to, but we're just having a single method, go to URL. And this is it. I showed you a few design patterns. Also, if you're curious, you can read and it's a little bit more complex. And I just wanted to touch a few simple design patterns. And actually in the book, this is something new. I haven't talked about the proxy and the adapter. Actually, there I talked about the decorator design pattern that you can find here. But I will just leave that to you as a homework to download the source code and check it out. Basically, it's similar. The decorator design pattern is similar to the adapter, but actually allows you to add additional logic to the one that we already have without causing any regression. So you can find it here. Also, there are a few articles online that you'll see in the description below. So I think these were the most of the things that I wanted to share with you about the handling weights in Selenium with Java. Next, as I said, we're going to talk about handling Selenium exceptions. There are many of them, and we'll talk in much detail about each one of them and how to protect against them. Thank you for watching. If you have questions, put them in the comments below. Also, I will be really happy to hear what you want to hear next from us. In the videos, share thoughts about the video, what you liked or what not. We really appreciate the feedback. And check the LambdaTest blog. There are many detailed articles there that are really awesome. And yeah, you can check the community LambdaTest. And don't forget to get your LambdaTest certification about Selenium and Java. Thank you for watching and see you soon.